Hey everyone, Kevin Griffin here. It's time to kick it in gear. Welcome to the Swift Kick Show. I am joined by my super special guest, Sidney Andrews. Say hi, Sidney.
Hello, world.
And we're going to give this a moment for. Oops.
Hello, world.
Ha!
Oh, got a
I
little
have.
echo action going.
Yeah, I gotta shut that down. But so I'll take care of that here in just a minute. All right. So let me get the other thingy live. All right. So we're waiting for people to come in. So, all right. All right. Okay. All right. So we're also going to cross stream this over on Twitch. So hopefully those folks enjoy it. Let's see. All right.
Yeah, one of these days I have to use my Twitch Prime subscription to subscribe to somebody on the dev side. 'Cause I think I did it with is it Jeff who does who does a regular Twitch broadcast?
Yeah.
Yeah, I think I did it once with Jeff.
You should do it with mine. Give me some credit.
There you go. I got to pass around. 'Cause I've been following Overwatch streamers, and I realized I don't actually watch. I just want somebody to get to subscribe.
All right, there we go. I put headphones on. It helps that echo so it doesn't screw me up. All right. Well, alrighty then. So let me hit this. All right, we should be good over here. And all right, Sidney, I think we're good to go.
All right, sounds good.
All right. I'm going to try something. We'll see if this screws up. What happens if I close my remote desktop window? Hopefully nothing blows up. Yep, it blew up. That was a bad idea. Sidney, why'd you let me do that?
I don't know what you're remote desktoping to.
Yeah, exactly. All right. So, hi everyone out there watching. If we got a low viewer count right now, so it's not a huge deal.
We're gonna go viral on YouTube. Don't worry about it.
Just an experiment. All right. All right, here's what I'm going to do. I'm going to turn the volume down on. So I have remote desktop open, and remote desktop is playing what you and I are hearing. So I hear myself and I hear you again in my remote desktop. And I'm like, oh, let me just close this. Well, that's a bad idea because if I close it, it doesn't go through to the Twitch stream.
Oh no, you don't want that.
All right, and we have a sound issue as well. Crap. Sidney, I broke everything. All right, everyone's going to yell at me. All right. So I shouldn't have closed the. All right, let me. All right. Why is the sound not coming through? All right. I still don't have sound. All right. All right. Yeah. Oh, I know. All right. Let me see if the sounds come back on. No sound. All right. Sydney, I have a problem. Here's what I'm going to have to do. I'm going to have to restart the feed.
Okay. Oh, one person dropped off.
I know. That's a shame because I'm. All right. Oh, you know why they dropped off? Because that one person was me. All right, let's try this again. All right. All right, Sydney, I think that's working.
All right, it's working now? All right.
All right. Cool. All right. We have sound again. So yay. That's a good sign.
We're going to edit all of this out in post, right?
Yeah. The post will have all this edited out. Sorry, folks out there on the internet. Very sorry about the sound issues. So that was actually just filler to get more people in the room, right?
There you go.
They come in because everyone comes in when they see a dumpster fire, right?
There you go.
Like, oh, let me just watch this sucker burn. All right, so we have folks in our webinar jam setup. We also have people over on Twitch. So if you're out on Twitch, say hi. We would love to chat with you. And let's see, Sidney, you and I were talking before jumping in here about the Visual Studio 2019 launch yesterday.
Right.
So, and then you admitted to me you don't use Visual Studio at all. You're a VS Code guy, like through and through.
So I want to use Visual Studio. I like Visual Studio, and I've grown up on Visual Studio, as in I learned how to use Visual Studio in college. But I do a lot with .NET Core nowadays. I do a lot of command line stuff. Most of my authoring is done in Markdown. I have to find a reason to open Visual Studio. And the biggest reason right now is if I need to create an MVC project. And now with Razor Pages, I don't even do that anymore. So it's kind of heartbreaking.
Interesting. Yeah, I've done my best to try to do a lot of my .NET work in VS Code, but I have so much muscle memory to Visual Studio shortcuts, specifically working in .NET applications, that if I get to, and also I have ReSharper and all that good stuff. So like if I get into VS Code, it's like, oh, I want to rename this variable. Wait, how do I do that in VS Code? Wait, can I do that in VS Code? All right, what do I got to do? So it's like I lose so much time just translating my muscle memory from Visual Studio into VS Code that it's almost not worth it. Like I don't save anything. But then I have things like, oh, I want to extract this method. And it's like, oh, wait. All right. I know how to do that in Visual Studio. I know how to do that with the ReSharper. How do I do that in VS Code? It's like, crap, I don't remember that as well. I want to find all instances of this function. It's like, oh, hold on. I don't remember how to do it. So I just end up not doing it. I just go back to Visual Studio.
So I guess I have to make an admission live, and this is terrifying. I don't know any shortcuts in Visual Studio at all. And I've never used ReSharper before, unless it's built in. I really don't know what ReSharper is. I hear everybody talk about it. Never used it before. I see those right-click shortcuts to rename variable stuff. Never used them. I just Control F. And then if something breaks the build, I go try and figure out. I'm sure I could probably be more efficient if I started using stuff like that, but it never happened. We blame a college professor who made us do everything in Notepad. Right before we got Visual Studio the last year. The Notepad before Visual Studio.
I do all my JavaScript and HTML work in VS Code.
Yeah.
Just because the tools, there's no special tools in Visual Studio that I wouldn't get in VS Code, and usually the only shortcut I need there is just some IntelliSense, and then just formatting my code. That's all I need. I know those shortcuts in VS Code. Although I'm more programmed to control KD in Visual Studio than like Alt Shift F in whatever it is in VS Code.
So I think somebody has a gist out there with you can customize every shortcut with using JSON, but somebody already has a user or workspace settings that swaps all the Visual Studio Code shortcuts for the traditional Visual Studio ones. And they actually, I forget, they maintain it somewhere. I think it was a gist on GitHub. So that's out there if you want to try that.
Yeah.
But the big advantage to me for using code is just how quickly I can spin up new windows without a thought, try out different ideas. And then if I'm working on an enterprise project, we're going to go Visual Studio for sure.
Yeah.
But most of the time, most of the stuff we do is so modular and lightweight that it feels like taking a sledgehammer to a nail.
Yep. So a couple of the cool things that they announced in Visual Studio 2019 was I'm really looking forward to trying out IntelliCode, which is machine learning over your code set. So the idea is if you're typing and you press dot or something that would bring up autocomplete, that the list of functions, members, properties, and stuff that you get isn't just an alphabetical list of everything that's available. One of the things ReSharper does is ReSharper pushes up to the top the ones that you have used most recently. But what IntelliCode does is like, well, we've analyzed every .NET project on GitHub because we own GitHub now. And we've built a model that says, well, if you say string dot, you're probably going to say string dot is null or white space or string dot empty. So we're going to put those at the very top and put a star next to them. So you have, you can get to what you need to faster, which I think is going to help a ton with new libraries I'm not familiar with. Let's imagine someone jumping into something like Dapper or JSON.net, and you hit dot and you get this list of stuff you can do. It's like, well, crap, which function do I need? But if they put stars at the top, well, most people do this, or this, but then you can do that. And I think what's even cool is that you can train your own code against a model, and you can distribute that model to other people on your team, so they can get the same benefit from the machine learning, but it's your own code, and they're not sending any intellectual property over to Microsoft. It's all done inside the Visual Studio.
So that's super interesting to me because as that model improves, I wonder how far into context it's going to go. So, like for instance, if I'm creating a read-only property that's initialized at the top of my class, and I do string dot, it's got to assume I'm doing some type of constant value. So string dot empty. And then everything else is either grayed out or towards the bottom. Whereas if I'm in the middle of a method and I've done some other string manipulation, maybe it can use some of the context. So I know now it's just using kind of like it's ranking methods based on use. But as that model improves and they bring in more and more context, they can kind of traverse that expression tree and start to see, sibling or nearby things that are being used to say, okay, in this expression structure, we tend to see people use these methods over these methods, even though method 2 might be the most often used static method. But in this particular context, it is not. So as that model improves, I think it's going to become weird 5 or 10 years from now, where somebody's just typing code and just hit tab, 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 tab. Oh, a little bit of text, tab, 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 tab. And then we're like, well, back in our day, we used to type out our methods ourselves. Have you ever heard of camel case? Because we did a lot of that too. So it's super interesting. I mean, it looks like was it IntelliSense and Skynet come together. But what
Yeah.
I'm really excited for is when FX Cop gets the Skynet treatment, and we start to get to a point where it starts giving it not on specific methods or anything, but start giving us some very hardcore opinions on the way our code is written out, a little bit more than how structured FX Cop is, but kind of get them more into semantics over syntax, and that whole push towards, can a tool using artificial intelligence makes our code more readable?
Yeah.
That's the next step.
Definitely. And it'd be great if they put like a little thing that says, hey, I noticed you repeat this code here, 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 and here. Would you like me to extract that out to a method for you? I think, and I think it could do that. It's like, hey, I've seen the pattern. It's like you're doing the exact same thing in these places. So you never know. VS 2021, I guess, at this point.
There you go. Or your variable names are terrible. Can we recommend variable names for you?
Yeah.
No one will ever understand what you're writing right now. We can apply some quick fixes before. Don't put this on GitHub unless you want to embarrass your whole company.
It's almost like the promise of the old case tools. If I could just explain my problem, it generates the program for me. That'd be great in this case, where I could say, I need a 3-tier business application that has this information, that information, that information, go. And then the model just goes, okay, well, here's what I've learned from GitHub. And it just, and not just GitHub, let's tie in the Stack Overflow as well and pull all that code in. It just generates your crappy app for you. And it doesn't have to be perfect. It just needs to be like 90% there. And then I can go fix the other 10%. Right?
There you go. Yeah. I never expect code to be automatically written, but if you can do 80 or 90% of the plumbing work, I do a lot of Azure stuff. So that's my whole pitch right there, is that I don't want to write code connecting different application components. I don't want to write plumbing code. I don't want to do, I love them for a long time, but I don't want to do WCF services and things like that again. I just want to be able to write a unit of logic and then let my orchestration system, even if I'm using something like Kubernetes, figure out what the plumbing and connections to each other are, because I don't care as a developer.
All righty. So that's enough about VS 2019. I mean, we could talk about performance and all that good stuff, but we spent too much time on my fails. So, Sidney, I want to turn it over to you. You're going to talk to us today about automating some stuff in Azure, and with .NET Core. And I just want to let you talk. And we have a good group of people out on Twitch that are watching us right now. So, Sidney, take it from here.
All right. Well, what I'm going to share today is actually kind of strange. What I do for a living, people ask me all the time, what do you do for a living? And if somebody's technical, I still have a hard time explaining it. And if somebody's not technical, it's just impossible to explain. For example, my family, including, my mom, my wife, it's taken 4 or 5 years for them to kind of understand what I do for a living enough to tell somebody else. But for the world out there, what I do is I write a lot of labs, demos, hands-on workshops, boot camps. If you see somebody on stage at a conference delivering a workshop, either one of the companies I compete against or my company has built that. And stuff's been used everywhere. So, for example, you were just talking about Visual Studio. Last year, the Cosmos DB team used a set of labs I built for the post-conference hands-on workshop. And so a lot of people say, oh, you build labs, so you just write a lot of instructions and try to make sure everything works. But it's actually a lot more detailed than that. Because back in the day, what we'll do is we'll give you a booklet, and then the first 5 pages are how to set up your environment. So spin up this, create this, or the worst one. We handed out a booklet one year, it was built 2015 or 2016. We said, install Visual Studio on your lab machine. And I don't know why I hated the attendees that much to put that in the book, but we had to tell them to install Visual Studio in order to do this talk or do this workshop. So we tell you to do a lot of stuff. And then after you've done all of this stuff, if you're still with us, here's the cool demo that takes 2 minutes with 15 minutes of setup. And so as you start to see these conference presentations get shorter and shorter, every person gets 2 to 3 minutes of stage time to wow you. I remember PDC where, Guthrie would take the stage for like half an hour, 45 minutes to do these really long, elaborate demos. But now you see Hanselman and Guthrie get up on stage. They got 5 minutes. They already have everything spun up. They say, here, run this, run that, run that. That's amazing. They're off the stage, off to the next product. So we had to do two things. One is we had to make the demos easy for anybody and accessible to get to. Two, we had to make it so that demo environments could be set up quickly and fast. And three, we had to make the demos compelling. So Hello World is just not compelling anymore. Everybody's seen it. So for example, last time I was on SwiftKick and did a webinar, I did a webinar on Cosmos DB. And I talked about how you can infinitely scale and has dynamic threshold allocations, and you can change your threshold if you want to give yourself more performance or if you want to save money. But that's just me saying it. Somebody be able to get on stage, show somebody how to do it, in Tokyo, and spin up an instance, populate with data, show somebody it dynamically scaling, and say, hey, see, here's an example. That's a lot more compelling. And so once I started looking at the problems, I looked at how all the other companies who are doing demos do it. They were still in the old ways. And I said, well, where do I go to improve this process? And the way I went about it is I talked to consulting firms. Consulting firms have a similar problem. And Kevin, I know with SwiftKick, you do your fair share of consulting. And so a lot of client problems fall into these nice little categories. And so a lot of times when I was consulting full-time, I consult now, but I consult and write at the same time. When I was only consulting, a lot of client projects were just falling into these same buckets. It was the same problem over and over again. So we started packaging proof of concepts and demos. So if we get a client says, oh, I was at a SharePoint consultancy a few years back. We had a client say, oh, we want to go to SharePoint Online. We'd have a packaged SharePoint Online demo that we could spin up real quick, jump to the client site, show it to them. They say impressive, and then we'll run from there. So I took what the consulting world did and said, how do we apply this to documentation, demos, labs? So even if you don't really work in the same space as I do, if you write documentation for other team members, for your clients, if you're consulting, you're giving advice to other clients, even if you're just in a traditional software development shop and you have to deliver a proof of concept to wow your boss so that you can get the hours that you think you need or the allocation you need on whatever sprint, we all have to build proof of concepts. So I really just took what I knew with .NET Core and just found ways to just containerize everything, and not containerize in Docker, even though we'll talk a little bit about that, but package is a better word here. Package everything so that it's neat and deliverable. So that's enough of me talking. I really want to walk everybody through like what I do and how this can help you out in your environment where you work. So I'm going to share my screen real quick. There we go. All right, so I have just a regular Chrome browser open here. And one of the first things I do is I do a lot of demos around .NET in the Azure Portal. And so if you ever go into the Azure Portal, one of the things you probably played around with is called the Cloud Shell. Just real quick, it's a containerized instance with tools that you need. Running whenever you open up the Cloud Shell, spins up one of these instances. You can run scripts in here. You can do all sorts of interesting things. And it's neat and interesting from that perspective. But it has tools built in so that if you want to write Python scripts, if you want to build out a .NET Core application, you can do this all within the Cloud Shell. And so one day, Scott Hanselman said, well, how many people go to the Cloud Shell website? And I'm probably like everybody else in the audience thought, you're talking about the Azure Portal, right? No. There's a Cloud Shell website. So if you go to shell.azure.com, sure enough, it'll ask you which Azure Active Directory, redundancy intended, you want, and it's the Cloud Shell full screen. And this was built because people are starting to use this as their main development environment. And that seemed weird to me, but then I started doing it. And especially if you're doing everything net new with .NET Core, you can do a lot of really quick demos, proof of concepts. If you have a client, you're saying, hey, let me show you how you use Entity Framework to connect to Azure SQL Database Instance. I can spin up that whole application here real quick. So the couple things you have to know with the Cloud Shell to be really awesome with it is that the Cloud Shell, if you dir, has one directory by default. It's called the Cloud Drive directory. If you've ever worked with Azure Storage before, it's just a SMB 2.1 file share. I can't remember if it's 2.1 or 3.0, but let's just say it's at least 2.1 to save ourselves some trouble here. So you got an SMB file share right here, and you could put files in there. So if we go to dir, we got a Cloud Drive directory, so we'll cd into Cloud Drive. And now that we're in Cloud Drive directory, I don't have anything in here, but I can make a directory. I'll call it demo app. Dir, now have a demo app directory. I'll cd into that demo app directory. And then I have lots of tools installed in here, but just for today, I'll just create a new .NET console app. So .NET new console. It's going to ask where do you want to output it. Let's put it here. And one of the cool things about the .NET CLI is if you specify where you want to output, it's going to give the CS project file the same name as the folder you put the project in. So since I call it the folder demo app, it's going to be demo app.csproj. So there we have 3 files, demo app.csproj, program.cs. And since we did a NuGet restore, we have a object folder, obj folder. Now, this is the one, and Kevin, hold on to your seat here. I think Kevin knows about this, but when I first saw it, I fell out of my seat. Scott Hansel was just doing a regular Azure Friday video, and he was like, I'm going to write code in the portal. Code dot. Boom. It's just crazy that this has been here for actually a while now. And I've been using it for at least about, I want to say about 6 months now, but it's been here much longer. It was just one of those things that's always been in the Cloud Shell and nobody's really talked about it. So they add a lot of buttons to make it obvious that there's an editor in the Cloud Shell. And you can get to it from the Azure portal too. So I'll just cd into Cloud Drive / demo app, code dot, same experience here. So from here, I could just write out, a regular application. I like to just, because I'm crazy, I like to just use the global namespace. So public class program. Trying to think, is anything else you need to include? I will need to say system.console.writeline. I just wanted to see, I accidentally opened Outlook on my machine. Sorry about that. I'll just run that .NET application. I'll scroll this up a little bit so you can see what's going on here. It's building. Hello world. We're done. Pretty cool. Now, we could do some more advanced stuff in here, but one of the things I ran into is that if I had these .NET Core applications, I want to put them in different environments. So if I want to put them on a machine, I want to put them somewhere in Azure. There were ways to package it, but none of it was really easy. And then I started looking at some of the sessions, SwiftKit webinars, and specifically at Brett's, one of Brett's sessions. And then I looked at some of the content that Brett and Kevin put out about .NET Core and Docker. And I realized I could just Dockerize my .NET Core app. Then I don't care where it runs. It can run on my local machine. It can run in Azure. It can run on a client's machine. It can run in a client's data center. It can run in AWS. Once I package this up in a container, I don't care where it goes. So it kind of gives me that goal of building that packageable proof of concept. So my natural instinct was to do what we do on a local machine, which is just a Docker build. So I'm going to do a Docker build. I'll just create a really simple Docker file. So it's touch Docker file. I'll just refresh the code editor here. I have my Docker file. And, I could put some content in here. And what I would do is I'll say, I want to use the .NET Core images. Now, you can go look this up, but there's it's from ncr.microsoft.com, .NET/core. And then wherever you want the runtime, the SDK, there's other flavors of the .NET Core image, but this is the root path. And so I'm going to get the SDK because I like to build something. Now, I need to know which version of .NET I want. So I'll save that. I go in here. I'll see that the Azure Cloud Shell uses Core 2.2. That's fine. So I'll say 2.2. And then here you can choose to use Alpine, Stretch, some flavor of Ubuntu, whatever you want. I'm just going to say Stretch. And then that's it. Now, remembering from Brett's recommendation here is that you could technically build and stuff in the root directory, but you'll run into some, especially depending on the type of .NET Core project you're doing, you'll run into some file path name length issues. So it's just easier to create a working directory called app. That just means everything I do from here on out is going to be in the context of this working directory. And then Docker will just copy everything from the local folder into that directory. Since our working directory is app now, that relative path right there is referring to app. Run .NET restore and run .NET publish. This is just like you would publish anything else. I'm going to do a release configuration. I'm going to put the result in the out folder. By runtime, I'm going to use Linux x64. And then I want it to be self-contained, so you don't have to have .NET Core installed on your target machine. It would be nice.
A little bit more zoom on that.
Yeah.
A little difficult on the render.
So is that a little bit better?
That helps.
Awesome. I can go in a little bit more. There we go. Okay, so from here, we have a really simple Docker file to work. But then we run into a problem if I'm using a Cloud Shell. I can't really do a Docker build, and I'll show you. If I run Docker build, I'll just do demo for my tag and build the Docker file in the current directory. It's going to tell me that while the Docker CLI is installed in Cloud Shell, Docker, the daemon is not running. And essentially, it makes sense. The Cloud Shell's free. Microsoft's not going to run the full, Docker, everything Docker on there. So a lot of people do their testing on local machine, and we can do that too. We have a DX Core Docker folder here. I'm going to .NET new console. I'll put into the current directory. Just because I'm crazy, I'm going to rename this DX Core Docker to demo app. I'm also going to go to the CS project file. And I'm running 3.0 preview on my local machine, but I'll just snap it down to 2.2. That's perfectly fine. And then right here in my application, I'll just copy the same application, test it out, make sure it works. So .NET run. Looks like it works. And then I could just do Docker build. I'll tag this test. Has to be built with a D. It's going to complain that I don't have a Docker file. I'll create a Docker file and copy that same code that we're using in Cloud Shell. Run the Docker build again. I've already downloaded the image, so step one was pretty fast. But if you haven't downloaded the image before, step one will take about a minute or two just to download the image and store it locally. So there we go. It copies all my files. It runs .NET restore. We're running .NET publish. It's fussing at me because I'm building a Linux-based Docker image from Windows machine. Yada, yada, yada. I'm ignoring it. Docker run it. I'll run test. We're now connected to that bash shell. You'll see that I have all my files here. And I have this out folder, so I can CD to out folder. And this is the actual result of me doing a self-contained build. So right here, you'll see I have my demo app. So I can just / demo app, hello world. So, nothing too crazy here. I could go in, change my program CS file. So maybe I wanted to create a more complex program. So I can go in and say, so instead of hello world, I can start doing some stuff like maybe with system net. So I'm going to first check network information, network interface, .get is network available. So that gives us a Boolean, whether we're connected to a network or not. If we're not, we're going to go in with say system console.writeLine, no network connection. But if we are connected to a network, we could just print out the IP address. But one of the things you got to remember is that you may have more than one device. So I'm going to just write out current IP addresses. Keep things really simple. Then I'm going to get my host name. The way I do that is system net. And I just memorized this so you don't have to. And I also have a sheet of paper because sometimes I forget the capitalization. Then system net, I'm going to get host entries for each IP address. So what I'll do is I'll call system.net.dns get host entry, pass in my host name.
Sidney, where are you typing? I don't see anything changing on the screen.
You don't?
No.
All right. Do you see something now?
Give it a second. I got a black screen. Just black screen.
Oh no, Visual Studio Code's not showing up. I'm gonna try it one more time. If it doesn't show up, I was proving a point with Visual Studio Code, but Visual Studio Code's not showing up.
Uh-huh.
And therein lies the rub. Okay, so what I was gonna do is I was gonna do a Docker build locally in Visual Studio Code, but unfortunately for me, as you just shared with me, it doesn't work. So what we're gonna do is we're gonna come back into the Cloud Shell.
Okay.
And do it here. I apologize about that. Thank you for letting me know. I would have went on for a while longer and not even realize it. So I'm going to get my IP addresses in my host address list. Hopefully I typed everything out correctly. So system.console, right line. And what I'll do, I'll just put a tab and then the address. So my goal here, just since the screen was black, I check the network's available. If it's not, print out no network connection. If it is, I print out a list of current IP addresses by calling get host name, get host entry, and then iterating over that address list and printing out the addresses. That way, if we have more than one IP address, if we only have one, it'll all work just fine. So let's test this application out, .NET Run. There we go. We see that's the IP address for my Cloud Shell instance. Now we'll go and say, okay, we want a Docker build. So tag test. And while we have a Docker file, it's going to, I forgot my Docker build tag test dot. It's going to tell me that we don't have the Docker daemon running. So we have to build somewhere else. And since we don't have a local machine to build over the Cloud Shell, I do all my builds using Azure Container Registries in the portal. So what I'll do is I'll go create a new resource, create a container registry, call this my company's name, C#run, create a new resource group called containers, hit OK, and then I'm cheap, I'll go to basic SKU. For most proof of concepts, demos, and stuff like that, the basic SKU is sufficient. You only go up to SKUs when you start to use container registries at an organizational level, and you need more registries. So looks like our container registry was successfully created. So the container registry is just like Docker Hub, but it's more of a private enterprise-y container registry. Not saying you can't do that on Docker Hub, just a different option. But what makes Azure ACR or Azure Container Registry, that was redundant, interesting is that you can run builds in Azure Container Registry. So we can do that using Azure ACR commands. So the first thing I'll run is an AZ ACR list. I could do a whole talk just on the Azure CLI. That's I'm super crazy enthused about it. We'll see I have one called C#run, and there's my login server. So I'll say I can do some queries here. So as the ACR list, a query, I'll get the name of everything there. I see it still returns a JSON array. Maybe I want tab separated values. I can do that too. I can even do more complex queries. So for instance, if you wanted to get the latest ACR instance you created, I can run max by, pass in my array, say use the creation date, which is a field up here, creation date. Oh, clicked on the wrong one, creation date. Run it, and it'll get the name of the most recent instance. We gotta do all sorts of stuff. It's pretty cool. Hit same query, but this time I get the ID. Oh, it's the JMES path syntax, which I'm probably mispronouncing. But if you learn that, you can do a lot of really crazy stuff. right here using those queries. So I have the name. I'll put in a variable called ACR name. If I did this correctly, I can echo that variable back out. Sweet. So now that I have that variable, I can call it ACR build instead of list. So build is my verb for this command. For my registry, I'll just use that ACR name variable. And then for my image, I can tell it what the name of the image should be. So this application checks my IP address, so I'll just call it IP check. And since we're just doing some demos here, I'll just call it version 1. Or no, let's just call it alpha. And I forgot one argument, and that's the source location. So before I put that in, let me explain what source location means. What ACR build will do is actually copy the files in that local directory or any directory you specify, and then send them to the build server. It actually puts them in a compressed folder. I think it's a tar file, and then sends it to the build server. The build server decompresses that folder and then performs the Docker build there. So even though we can't do a Docker build here, we can do a Docker build there. So hit dot, tell them just, use the current directory. There we go. Pack in our source code, upload it, setting up, pulling in the .NET Core SDK image, and I believe for our Docker file, it's 22 stretch. So it's downloading that image. Then once it's done downloading the image, it's going to switch its working directory. Copy that code that we sent to the build server over, run .NET Restore, and then create a published version of our application. Now, while it's building, we could get fancier with this if we wanted to. So, for example, the SDK image is a really big image. So if you, in the future, wanted to slim down stuff a bit, you can actually pull in the .NET Core runtime image, and I'll just use 2.2 stretch. But they even have another version called Stretch Slim, which just has even more stuff removed to, again, make that image as small and remove as much overhead as possible. If you were to pull in a second image, you have to do, or second container image, you have to do a couple things. The first thing is I'll add an alias here, and then I'll run my copy command again. And I'll say from that build alias, copy the app directory /out, because the working directory is called app, and where we put our output is out. And then in our destination container right here, the runtime, we'll just put it in root. Because we're not building in the root, we're just putting it in the root. We'll save it, and that's a new version of our Docker file. And I was just showing you that while we were testing things out. You'll see, here we go. It ran changed our working directory, copied the files over, ran .NET Restore, published our application, and it's finished publishing our application. So now it's pushing version 1 of our image, or alpha of our image, to Azure Container Registry. So if I go back here, go to my resource groups, go to containers, I'll see I jumped a little bit ahead of the gun. So it's actually right here, waiting, pushed. So it looks like we got maybe 1 or 2 more left to do. But what it's doing now is it's finished building, and it's actually saving or pushing that image into our repository in Azure Container Registry so that we can use it with different applications. So I'm just giving it a second to go. The reason I do this is because using the container image, I can distribute these proof of concepts to other people. So for example, if I had a public registry like Docker Hub, I can point the clients at my Docker Hub registry. If it's an enterprise, like we're all sharing things within a company, I would use a private registry like we're doing here with Azure ACR. And the cool thing about Azure ACR here is that it handles build and everything. So I can do builds on somebody else's box. I don't have to worry about local build versions or anything like that. So it looks like it's finished. I refresh. I have a repository container called IP, or container image repository called IP check. And it has 1 version, which is my alpha tag. So I can actually deploy this to container instances so that we could just run this code. And there's a couple of different ways we do this. This is where things start to get really interesting. If I want to deploy this, I would have to set up certificates and things so that you can have access to container registry. There is a shortcut. If I go to overview here and hit update, I could just enable a username and password. It just makes it easier for demos and stuff to deploy. I wouldn't do this with anything like, super sensitive or anything like that. But again, in the contracting side of things, if I'm doing proof of concepts, I'm doing examples, I'm building things out, I'll go to path of least resistance. So here in my IP check repository, I go in, and now that I create a username and password, I could do things like run instances of my container. So here it'll say, go get the container instance image called IP check, tag called alpha. I'll just say this is alpha easy demo. I have my resource group called containers, and I'll just leave everything else set to default. So it's going to spin up a container instance in the cloud with my container image on it. Now, you would think, okay, you're done, but one problem here. I haven't actually told my container to do anything. So what it's going to do is going to spin up the container instance, and it'll have nothing to do, and it will spin down. And Azure Container Instances is a pretty smart service. So what it'll do is it'll see that it's just constantly spinning up and spinning down. There we go. It's in a waiting state. So after a while, it's just going to give up on it. So there we go. Pulling, it backed off, failed. So it attempted to start this container 3 times already. And it's realized there's nothing for it to do. So we have to actually tell Azure Container Instances what we want to do. And the way we do that is through what we call run commands. So let me show you how you create Azure Container Instance or run a run command. So we have container instances right here. I'll just say alpha manual. That's what I'll call it. I'm going to pull it from private container registry. So I'll just open up a new instance of the Azure portal. I have my registry right here. I'm going to need a couple things. I'm going to need my container image name. Luckily for me, I remember how to get the image name. And this is true for any container registry. You get the login server / IP check alpha version. I've already copied the login server, so I'll put it in there. Username is typically the name of the service, and I'll just copy one of my passwords. I'll pop into the containers resource group, hit OK. And then here, you'll see that earlier, it just had like 2 options. But here, we got all the options. And one of the options down here is called a command override. So normally, your container has an entry point. You tell it what to do when the container should start. So Kevin, I don't know if you've done Azure Web Apps for containers before.
I have not.
Okay, so if you do Azure Web Apps for containers, you have to actually tell it. You have to tell Azure Web Apps to run the or whatever name of your application .dll to start your web application. So that's you're telling it what command to run on the container. So we can do the same thing here. So I could say I have my demo app in the root of the application. So just run that demo app. And I'll leave everything else set to default values. It's going to validate that I'm not crazy. Hit OK. And it'll take a second, but it's actually really fast. And I jumped in too fast. I'm trying to give it just enough time, but it's always faster than you think it's going to be. So let's see. There we go. It's pulling the image. So that means it's downloading the container image. Hasn't started yet. But what I expect it to do is run that demo app application. And then when it's done, it's going to just terminate and shut down. So giving it a second to pull down the image. This is one of those things. It's like a watch pot boiling. Now that we're watching the pot, it's not going to boil. We just go out. This is what happens when you just do things too fast. Don't tell anybody, but I control F5 my
I've done that.
There we go. It's killing me. I wonder why it's taking so long. Well, the great thing about container instances, I'll just bop it. I know that's not technically the term that we're using, but I'm just going to restart it. So it's restarting the group. There we go. This is the part, there we go. It pulled the image. It ran it. Uh-oh, looks like I did something wrong here. You see that failed message right there? That means something happened. So maybe I typed in the name of the command incorrectly. So what I can do is I can go back and look at what I set that start command to be. So in this example, I set the start command to demo app with a /. And now I'm wondering if it should have been a /. So I'm going to go and just do this again just to make sure I'm not crazy. So I'll create a resource. Alpha checking if I'm crazy. My container image name, I'll get my credentials from here. Username, password. Okay. Hit okay here. Just deploy that again. All right, so while that's deploying, what I really want to get to is I want to get to a point where I can automate the creation of these instances. And the way I do that is through Azure Resource Manager templates. So if I go back to my easy demo, you'll see here that if I go to export template, I can actually get a template that will deploy my application and set the commands and everything for me. So here, this JSON, well, let me just do one to keep things simple. This one JSON object represents my container instance, the actual image I'm running, the command I wanted to execute, what ports I wanted to open, and then things like resources. So I can automatically create these container instances. So things get really interesting because I can do some advanced stuff. So I'll show you an example of this. On my GitHub website, I have a repository called Cosmos Demo. As part of a project building demos for the sales team to actually go out and run these 10,000 records a second upload strings to show how you can dynamically scale in and out throughput. So if I go to this console application, I wrote this console application .NET Core, and I created a Docker file it's a little bit more complicated, but it looks very similar to what we looked at before. It has a runtime and SDK image. It runs restore and publish. And then I created a JSON file here that's going to look really similar. It creates a Cosmos account and then creates one of my containers. But it does this one weird thing that I haven't shown everybody yet, which is right here. Instead of running my application command, I run tail with the F flag dev null. So what I created essentially here is the Azure equivalent of a Jumpbox. So I created an Azure container instance that's going to run in an infinite loop. And then I can connect to that using the bash shell and then run my .NET Core console applications. So using that example, I'll show you how I can deploy this template. So I'll go to template deployment, deploy custom template. And luckily for me, I have the template already. So I'll just hit build your own template in an editor, copy and paste this. And everything looks very similar. The only thing I have to update here is the password. So I'll just open up a new instance of portal.azure.com, pull in my container registry, and get my password and pop it in. But I just wanted to walk through this real quick. So I give it the name of the container I want. It creates a container instance in the East Coast using this image name. Instead of V1, I use the name alpha. It runs it in an infinite loop, so the container instance doesn't stop, it's always running. And then it tells it how to connect to this private image registry. So I hit save here. I'll put this in my containers group, and I'll call it built automatically. And I do my custom deployment. So now I have a single text file that can deploy my entire demo. And we use this with this Cosmos demo repository to deploy multiple container instances with these test applications to do stress tests, load tests, so that while somebody is walking through a presentation, they can say, well, here's an example of uploading 100,000 documents and how long it takes if we have 100 RUs versus 1,000 RUs. And the idea there is that this is the type of stuff we have to demo to people all the time. So I'm going to refresh, and there's built automatically. It's pulling the image right now. And while that's pulling the image, I want to tell you, like, there's one huge advantage to using these JSON templates, and that's we can distribute it to other people without having access to the Azure subscription. So while I'm waiting for that to pull, let's go to this JSON template that I just used. So I'm going to go to gist.github.com. I'm going to create a new gist. I'll just say Azure deploy.json. ARM template for ACI. And I have everything there. In the real world, I wouldn't share my private registry credentials. What I would do is I'll go to something like Docker Hub. So I have a Docker Hub account. I can go to hub.docker.com/C#run IP check. Here we go, just trying to get back to, there we go, C#run/IP check. And I see I have a tag called latest. So I'll just do C#run IP check latest. And use a public, just the difference here is I'm just using a public image repository, because I'm thinking about it from if somebody's doing a hands-on lab, if it's a client, I don't want them to have access to my private registry. So I use something like Docker Hub. So here I have C#run/IP check latest. Everything else looks good. I'll create a public gist. Now, the great thing about this is this public gist has a raw URL where you could get to that JSON file. So then I could build something pretty crazy. So I'll pull up a URL encoder in Bing, copy this file in, encode it, and there we go. I have a URL that's now URL encoded, and that's totally on purpose. Then I'll go to portal.azure.com/create Microsoft.template/URI, and then paste in that long URL. Hit enter. It's going to take me directly to the custom deployment screen with the template pre-populated. So now what I've effectively created, I'll word wrap this and make it bigger so you can see it. What I've effectively created here is a URL to deploy this template on anyone's subscription. Now, that's awesome in and of itself, but the thing is, you can start building documentation around it. So I'll show you a really good example of that. If you look for the Azure Quick Start templates, this is a GitHub repository of a whole bunch of templates people in the Azure community have built for proof of concepts, demos, examples. Even if you're just building a new project, you get it started. One of the things I like to do all the time is build a function app, but I like to deploy code to that function app from GitHub. So here I contributed one of the templates where it creates an Azure function and deploys code from GitHub. And the JSON's right here. It's been updated with location parameters. We see that it's a little bit more involved, but it's a JSON template here. And this button right here is that same URL I just showed you. As a matter of fact, there's other tools like armviz.io that allow you to visualize your template. And just jump right back. And if I click deploy to Azure right here, boom, it'll open up the portal with this template already there. So using this, if somebody's doing a hands-on workshop, if I have a client I need to deliver a demo to, if I have somebody in my organization, I want them to try something out in their MSDN subscription, I can just give them a URL and an email. And I do it all the time to do this. So while it's stalling, you'll see that my container is created, it was started, and it's running. So this was the container, if you remember, I ran tail dev null. So basically it's just doing an infinite loop. So I could connect to it using bash, dir. I see that I have my demo app.cs proj, my Docker file. I have an out folder. So I can cd to the out folder. There, I have my application. I can run demo app and see the IP address for this container instance. So using these methods I showed you today, essentially what you can do is if you could think of anything in .NET Core, you can Dockerize it, put it in Docker Hub, which is probably the easiest path. Or if you're in an enterprise and you have to protect everything, put it in an Azure Container Registry and just deploy it in it over and over again. If you're deploying it outside your organization, use Docker Hub so you can use ARM templates like the ones I showed you today to deploy to anyone's subscription anywhere. If you're within an organization, you'll just use an ARM template with your password baked in. The biggest thing, though, is that if you can package everything up like this, you can start building some really interesting proof of concepts that are customized per client. You can set up, so a really good example of this is I have on that github.com demo that I showed, the actual .NET Core application I used, if I'll just jump into the program and CS so you can see this, I used a library called Parser, which, by the way, highly recommend. The library is called Command Line, but the class is called Parse. I apologize. But this library is awesome because I can parse the args, and then what I do when I parse them, I can map them to a class. So I have a class called Options. I'll just show you that. And so by mapping it to this class, I can actually create options. So when you run this command line application, I can say -T is the type of benchmark you want to run. -L is the location where you want to run this benchmark. -D is which database you want to run this benchmark on, which collection, and how much throughput to use. And I have enums for some of the common values. So using this, I was able to build a Azure Container Instances template, ARM template. And we were able to use a lab environment. We used our Learn on Demand systems who do a lot of labs that ignite and build. In their environment, they just deployed ARM template, and then the person clicks the button to start their lab. And when the lab started, the container instance is running, because remember, we're using devtail null, and the person just hits the same thing you just saw me do, which is they hit containers, connect, and now they're running here. They can run the .NET applications. They can run it with all the flags, just like I showed you, so they can run it with the T flag, the location flag. And so a really good example of this is that one of the things we do is we'll deploy a container instance to WestUS, and we'll ask them to connect to the Cosmos DBA account, connect to it using the Chinese endpoint, and they connect to it using the East US endpoint. So you see the difference in latency. And then they will have to connect to another container instance running on the other end of the globe, so they can see how in that demo, the product team's goal was to show everybody that their database was essentially a dynamic CDN because it was putting content closer to the end user. And we're able to do that. We also did something similar to this when I worked on some stuff around, excuse me, around storage. So we're building out labs for people who are taking the new Azure 203 certification, and they wanted to be able to pre-populate storage accounts. So what I did is I created a .NET Core console application, and I used the same code that you will always use with a .NET Core console application to connect to Azure Storage. And then from Azure Storage, I created blobs, and I created they're not real folders, kind of pseudo folders. You just manipulate in the blob name. So I pre-populate the storage account with information. I put in a container instance, and then I created an ARM template. And so whenever this container instance is created, it runs the command. So it was called populate app. It ran populate app once and then stopped. And once it done that, everything's good to go. Everything's hunky-dory. The storage account is populated. So when the person went to go and try out Azure Storage for the first time, it had blobs and files in there. And it was really great to get people to try it out and see and say, hey, yeah, this is pretty cool. And I did something similar with ASP.NET on Core web application. Had a Razor Pages application. I was trying to convince a client to use Razor Pages. So I built a demo website, but I also wanted to build a demo SQL database, an Entity Framework. I used Entity Framework connect to that SQL database. But as everybody's ever encountered, if I wanted to populate it with content, I either populate it with AdventureWorks or I have to do some manual steps. But no, I am far too lazy for that. I used .NET Core. I built an Entity Framework application that all I did was populate the database. use the same libraries as the actual ASP.NET Core web application. Then I built a second container with the web application. So the first container was hosted in Azure Container Instances, and the second container was actually hosted in the Azure Web App. And the second container didn't spin up until the first container was done. And once the second container spun up in Azure Web Apps, the web application already had pre-populated data. I essentially created a demo in a box. And if you ever go into Azure Portal, use the Azure Marketplace, that's exactly how they're doing a lot of this. And, I showed a lot today, so there's probably a lot to digest. So I recommend, if you watch it last stream, go back, watch the recorded version. This is kind of what I do for a living. It took me 2 or 3 years to get super comfortable and doing this all the time. So it's a rabbit hole. One of the big problems we're trying to, well, not problems, but one of the things that the team I work with, we're trying to work on right now is how to use things like managed service identities. So we can actually create a managed service identity associated with the container instance. And that service identity has the credentials. So if we want to connect to the SQL database, the storage account, the Cosmos DB account, so that we don't have to bake in credentials into our container or even pass them in as environment variables. Matter of fact, we never pass in credentials using this new method. So that's one of the things, we're working on to kind of evolve this process. And the next step beyond that is how do we go beyond 1 or 2 containers at a time? How do we actually deploy a whole cluster of containers to do an entire environment spin up? My vision here is to be able to just give somebody a URL and deploy 15 to 20 service instances in the Azure subscription with the full solution completely built out without any human intervention whatsoever, so they can try out our solution. And then if they say, yeah, that's exactly what we're trying to do, we could go in and then, I'm a consultant, so we can go in and say, all right, well, here's how much it costs to build your product. And, these techniques, we're sharing it out because I want people within your own organization. I don't know how many times as a developer at a desk, I felt like, oh man, this company will make so much more money if you let me do it X way instead of Y. But there's no feasible way for me to build that out. But using my MSDN subscription, some of the techniques kind of shared, I know I was able to do it. Anybody can do it. You can go in and build your own proof of concept in your own subscription and say, hey, boss, look at this proof of concept. And they say, okay, I want to play around with it. All right, here's the URL to deploy it to your subscription. Let us know how it goes. Deployed it, poked around, says, okay, make X changes, Y changes, and now we can justify and go off and build a new feature on our product because we're able to visualize and justify, the stuff that we always say we want to do. Now we can actually build out proof of concepts quickly and easily. This just, in my mind, this just reduces the friction to building proof of concepts completely. So, Kev, I'm telling you, man, it's a lot, but this is my day-to-day. So when people say, oh, you write labs, and I was like, oh, I told them I write labs, and they were like, oh, that must be so boring. It is not. This is awesome.
Nice. So I was making notes of like little things I learned during that. And I'm in the Twitch chat with a couple of folks. I'm like, holy crap, did not know about the shell editor, didn't know about the shell like website all by itself. I mean, and yeah, and can I post the link to that gist that you?
Yeah. So I shared it out on here on webinar. You can share it out on YouTube, Twitch. I just for everybody else, I include the links to 2 gists with all of the code I ran today, plus some more. I had a local Richmond.net user group, a Richmond, Virginia.net user group, and I gave a 2.5-hour version of this talk where we built everything from scratch from the ground up. And so all the code we built is there in the 2 links that Kevin's sharing now. It's fun. It's pretty cool.
All righty. Well, let's see. I'm keeping an eye on Twitch. If anyone has a question before we shut down, now is kind of the time to throw it in there. Again, thank you, Sidney, for hanging out with us. We're going to do this SwiftKick show thing again in about 2 weeks. I think actually I'm going to do the talk. I have a new talk I've been polishing on upgrading your ASP.NET Classic skills. Full .NET framework, that's now ASP.NET Classic. I'm trying to key that term. So if someone says, "Oh yeah, I use ASP.NET 4.5," I'm like, "Oh, use ASP.NET Classic, okay." And then and make them fill. It's like, what? I'm not using the newest, coolest stuff. I'm like, yeah, you're not on core. Everyone's on core.
So
like,
classic is not for the developers. That whole classic word is for management. Because then I could go to my boss's office and say, we're using ASP.NET Classic. Yep. Oh no, we need to get to something that's not classic, because classic makes them think deprecated. I'm telling you.
Yep. It barely is. I mean, supported, but they're not getting any new features. In ASP.NET Classic, you need to move the core. So folks who are making that jump from ASP.NET, say 4.5 to ASP.NET Core 2.2. What skills do you need to have in order to make that jump? And it's not a huge leap in syntax. It's just, hey, let's think about a life without IIS. Let's think about Kestrel first, and let's talk about dependency injection as a first-class citizen. Let's think about all these things that you didn't necessarily have to think about with ASP.NET Legacy. So,
you're being so nice. I'm telling you. If you consider .NET Core, async main. That's number one reason for .NET Core. I cannot go back to static void main.
Yep. So folks out there, get ready. Look out for that on Twitch. You can also go to our website, swiftkick.in, and get on our mailing list, and we'll tell you about it when it gets scheduled. But with that, I don't see any questions in Twitch. So thank you everyone out there on Twitch. We were also being hosted by the Visual Studio channel on Twitch. So you're to those people as well. And Ed Charbonneau, he was hosting us as well. So thank you to everyone who watched. And we'll see you all next time. So thanks, Sidney. I appreciate it.
Yeah, thank y'all.
All right.